So thank you for kind introduction. And first of all, let me thank all the organizers to invite me. This is my great honor. And also, thank you for coming this morning on a slightly rainy day. Then before starting my talk, let me give you some brief advertisement because I'm general chair of the Bracket Programming 2023, and which is held in Tokyo next March. And unfortunately, paper submission deadline is over, but you have still a chance to send that paper to the workshops. And the workshop deadline will be end of January, well, middle of January. And if you send a paper, you get a ticket to Tokyo. So please come again to the Pacific Rim area. Hopefully, it's a little bit shorter than Europe. Okay. So let me start my talk. The title is this. Sounds a little bit provocative, but well, the reason I came up with this title was I got a question from a student at our university. He said at the class, he said, I spent many years to learn a programming language. Why do you try to develop yet another language? It's sad. It's a kind of sad question. Because he said that he doesn't want to learn no more language, but just one language is enough to learn. So for his honor, I have to tell you that he's not Python only machine learning kid. He was a grad student, and he was seriously researching, studying IP. He's basically IP networking guy, so he's good at developing a router and TCP IP stack, IP v6 stuff. So he's really he's a grad student, but he's sort of a professional programmer. But he said he doesn't. He said the C++ is good enough. He was happy with only C++. He doesn't want to learn in JavaScript, Java. Well, other, Rust. Maybe Rust would be okay for him, but anyway. So, but the interesting thing was, nowadays, people, maybe young generation, I should say young generation, I'm getting old. Young generation say they don't want to learn a new language. But this is my observation. They still seems to accept that, they have to learn a new library. So they don't want to learn a language, but learning a new library is okay. So this is, I think this is an interesting phenomena we can see today. And that is not the only word from young generation, also from elder generation. I found an interesting video on the net. At the list NYC, New York, I think it's a New York City meetup held in 2016. Professor Sassman said a very interesting thing, because after he gave a talk, a very interesting talk. If you're interested in, check that video or just Google it. After the talk, one of the audience on the floor asked him a question: why MIT stopped teaching his famous SICP textbook? Well, just in case you don't know, he's very famous of his structure and interpretation of computer programming book. So it's kind of the textbook for us. I mean, to me at least, when I was a grad student. His answer was very interesting. He said, since he wrote that, very nice textbook, programming style has changed. He said that programming is not, nowadays, programming is not analysis and synthesis. Well, his book is basically on that, line. Well, first of all, we have to analyze a program, break it into smaller pieces, and write a code, synthesize them all, and to make an application. So the textbook was written along that line. But he said nowadays, programming is basically to observe and poke the code, like science, like natural science. it's not engineering, it's now science. And he said the programming is basically to answer the question, can I tweak a library to do what I want to do? So that's programming activities nowadays. People are So actually, I mean, even I also observe my students, and they Google it and download some software libraries and try to tweak it to fit their goal. So the bottom line is we are now in the era of libraries, not language. So that might be a very big crisis for us. I'm happy to be invited by Software Language Engineering Conference. But, well, my observation said, the story so far said, we should rename the conference. But it's okay, we are lucky. SLE is a very good name because we can just simply, silently update our website, Software Library Engineering Conference. Please submit the papers to the next year. It's kind of a joke. Don't worry, we don't have to change the name. So this is my third law. Any sufficiently advanced library is indistinguishable from a language. So basically, library is indistinguishable from the language. So when students are learning a new library, I think they are accidentally learning a new language, which they hate. So that's my observations. So from now on, I would like to talk about my thought, a kind of simple thought. Nowadays, a library is a kind of a language, and that's what we have to seriously deal with. So let me briefly overview the kind of history. So today, well, what I want to say is today, a library is not as simple. In the good old days, well, I show this story to my students, grad students, and no, he's not a grad student anymore. He's my colleague. He missed the, well, I should stop. The only person who joined the last session yesterday knows what's happened. He said, good old days, library was still library like today, but I'm saying good old days means, well, 30, 40 years ago. So in those days, on those days, a library was a collection, just a collection of functions. So functions did not have internal states. They are mostly stateless. So basically, all the things has to be passed to the function as arguments, and even the output is written back on the argument and send it back. So the function library functions do not maintain any global variable, kind of hidden global variables to hold the state, maintain state. So it was very simple to use. Everything was explicit. In a state, it has to be explicitly given to a function, and you don't have to care about that. What's happened inside, under the hood. Then a library was getting called a framework. A framework is not a collection of simple functions. It's in an incomplete application program. So the users of those framework library has to fill out the missing pieces in the code to complete their program. So the style of using library was totally changed. In good old days, on good days, they simply pick up the library functions and combine them and write the rest of the code. Main function, they have to write the main function. But when they use a framework, they don't have to write a main function any longer. Basically the thing is just read a manual and fill out the missing pieces, like event handlers and event handlers, event handlers, event handlers. That's all. So that's a day of a framework. But today, I think a modern library is called an embedded domain-specific language. So library is now a language. I think there is a reason, because library uses a code should look declarative. I mean, from the viewpoint of the library developers, they want to make the library users code, not the library implementation code. Library users code should look declarative as much as possible. So now it's a user's code is not a set of commands, it's a sequence of commands. On good old days, basically library users code was a kind of collection of function calls. It's a set of commands. But nowadays, the code should look like declarative code. And the library implementation has to hide the states, to make the code declarative. So that's why today's library is sort of a language. Well, it's not general purpose language. It's embedded DSL, but it's a library. It's called library. Let me show an example. So even in the second phase, framework, some sort of a framework was called a language. I found an interesting question on Stack Overflow. One person asked the people why Ruby on Rails, which is very famous web application framework written in Ruby, why Ruby on Rails is called a domain-specific language. Here's the point. The person who made a question believes Ruby on Rails is a language, a domain DSL, but he couldn't find how to explain why Rails is called DSL to his colleagues or students, I don't know, younger people. So he asked the question. So here's the point. So the interesting thing is that many people believe that Ruby on Rails is a framework written in Ruby, but it's a language. Let me show a kind of sample code. I just found on the web to show today. This is a kind of piece of code written in Ruby for Ruby on Rails. So look, this is a totally valid Ruby code, and no syntax extension is done. But I suppose you see this is very declarative. So I think this is a definition of database schema. So first you have to say active record scheme, blah, 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 and say create a table. And the first column is that type is integer, and the name is article ID. And the second thing is, again, it's another integer, and the column name is kind, blah, blah, blah. So it's very more like a SQL. And I hope you agree that this is very declarative code. But if you know Ruby, so this is just a simple, sequence of function calls. Because in Ruby, you can omit lots of parentheses and semicolons and other sort of redundant syntactic symbols. So you can make it, you can make the code look declarative, but it's just a regular program, a regular object-oriented program. So, but anyway, because modern languages provide very flexible syntax to implementers and users, if you carefully design your library, you can make it like language. So that's why I say modern library is sort of language. Sorry, I'm confused. Library is a language. Well, both words start from L. And it's good. It's very bad for Japanese people to say L and R. Ruby and library language. Maybe my pronunciation is okay, acceptable. Although Ruby doesn't give you any ability to extend syntax, but if you look at many academic conference proceedings, you can find many research proposals to make the language syntax more extensible. And I know maybe most of people want to say, why don't you talk about macros? But I know macros. But there are so many papers and practical activities. So I just want to skip macros. And I believe almost maybe 80% or almost everybody knows how to use macros for syntax extensions. I just want to skip. But well as macros, I like macros. I never brain. Another proposal has been given. For example, one of the promising approach is to let programmers to define their own operator. So that could be a rescue for the syntax extension. So here the user-defined operator allows you to pick up an arbitrary operator name, and the operator doesn't have to be an infix operator. It can be also a prefix and postfix operators. And also many systems try to support not only unary, but also binary, trinary, n-ary, any kind of function, any kind of operators. So in those systems, you can define select from where operator. Now select is, operator can use not only symbol, but it's also identifiers. So you can pick up a select and from and where as an operator names and define operators. It takes 3 operands. So it's still operator. So if the language provide this kind of extensibility, ability to define a user-defined operator, you can freely extend the syntax and give your users more, fancy expressive expression representation to make library more language. But yes, scoping is a challenge. So if you do some survey, you can find lots of techniques to avoid scoping problem. So let me tell you introduce one of them. So the question is, where is the user-defined operator available? If you allow users to use operators at anywhere, that makes a big confusion. So first of all, in a previous slide, I showed the select from where example, but select would be used as a variable name in other parts. So it's make a big confusion. And also another more serious problem is the parsing. So the parser have to, if your language accept the user-defined operator, the parser has to understand, this is a user-defined operator. This is just a normal variable name, and so on. So it's quite difficult. So without scoping, it's very difficult to parse a program including user-defined operators. So I tried to come up with a good example, but I think it's failed. But well, maybe semicolon is sort of another user-defined operator, which is equivalent as a comma. And maybe equal operator is kind of user-defined operator to be equivalent to a plus operator. In that case, this example should make sense. There are a bunch of proposals to avoid a scoping problem. Maybe there are more, but I found Wyvern and Protege. And the second one, Protege, is from our group. So let me introduce a little bit about Protege as an example to solve this scoping problem. So an idea used by Wyvern and Protege is to make a scope, to use expected type to make a scope. So an idea is very, very simple and straightforward. So in that case, in that example, so parser first tried to read the left-hand side of equal operator, assignment operator. So it found that, okay, the variable is IDS, and the type of variable is result set. So the right-hand side, on the right-hand side of the equal operator, the expression has to returns a result set value. So the parser thinks that okay, if there is a user-defined operator returning result set type value, the value of result set type, it's available. Otherwise, other operators, the parser can ignore it. The parser can ignore the other operators. So it's scope. It's a make a scope. Of course, maybe parser has to do some backtracking. First, try this operator. It fails. Back again to the equal operator and try another grammar. But anyway, to support the user-defined operator, the parser has to dynamically extend the syntax, grammar definition during the compile time. So the compilation process is parsing process is a little bit complicated. But if you introduce this kind of a scoping rule, that reduces kind of expected time for parsing, and you can make the parser more practical. Otherwise, it may, in a worst case, it takes too much time for parsing. We also extended this idea, and we extended the type system to support this kind of user-defined operators. The name was trans-style type, because the type name is like that. I mean, bar R bracket T trans-style bool. So that's a trans-style type. The idea is very simple. So we just simply add the information on which user-defined operator is available in an expression resulting in that trans-style type. So with this trans-style type, you can implement this kind of fancy user-defined operators. So this user-defined operator is a select from where operator again. And the first operand has to be string, ID. And the operand following from has to be a type of DB, database bracket T. T is a type parameter. And the type parameter T should be bound to some type derived from DB papers expression. So, and then this tensor type says, when you pass r.year equal 2022, some operators given by bar rt bracket t are available. And bar r type says the operator r, this is a operator without any operand is available when you parse this expression. And also r.year equal 2020, 22 is translated into a func or a function. So you can write your users, when you define this operator as part of your library, your users can enjoy this very much like a SQL code in his program. So that's an idea. Okay. Let me go back to my previous slide, my silo. Any sufficiently advanced library is indistinguishable from a language. I would like to show another example. Ruby on Rails is just one. This is more fashionable. today. I like to show this slide when I present my grant proposal, because people are happy, grant agencies are happy to see Python. Ruby is not popular. Well, it was developed in Japan, so I suppose the government should support that development of the language because that's our own. But they prefer Python nowadays. That's sad. This is a program. This slide shows that two pieces of code, which the left-hand side is written in NumPy, which is, classic library. I mean, in my sense. And the right-hand side is the code written in TensorFlow. The two pieces of the code do the same thing. But obviously, the code written with TensorFlow is much shorter because it's a language. For example, you don't have to implement backtracking because this TF TensorFlow gradients does all the messy things. So like a Python only kid, machine learning kid can enjoy this code. They don't have to really learn what's going on. They don't have to really learn mathematics. That's today's programming, unfortunately. So I say TensorFlow is a language because it looks like a Python code, but it's not really Python. For example, to learn the code, you have to write this, kind of very ugly code. You have to explicitly run, and also more importantly, you can't use control flow statement available. That should be available in Python, like for statement and if statement. When you write the TensorFlow code, you have to use if and control flow structure provided by TensorFlow, not Python one. This is very problematic, and actually I found blog entries written by someone I don't know. This person said, this person said, which Python, which libraries or language is better, PyTorch or TensorFlow? As you know, nowadays people start using PyTorch, not TensorFlow. For example, this semester, one of my fresh new grad students said, he's interested in machine learning. So I said, okay, let's learn it. And he went to a university library and borrowed a book written about TensorFlow. And then in the next meeting, he said, I read this book, but the code in the book doesn't work at all. So maybe the version is too old. So I said, why don't you use PyTorch? TensorFlow is obsolete now. So the guy said, this person said, PyTorch is better because when you use TensorFlow, as I said, the programmers cannot use Python's control flow, original control flow, like a for statement or if statement. That's a big problem for end users. So that person said the TensorFlow language is a loser. But this is a very sad story for us because, as you know, PyTorch is a library language, DSL, but it's based on a little bit the classic approach to develop the embedded DSL. And in my sense, TensorFlow is a more modern library, modern language library language. So as a researcher in this community, I would like to push TensorFlow more because it's based on more advanced technologies developed by us. But unfortunately, normal people prefer PyTorch, which is based on a more classic, older version of the technology. So basically, PyTorch is a embedded language based on a shallow embedding. So it's more like a more older style of embedded DSL, embedded DSL. But yes, it's still language. I think the code is much simpler. Again, you don't have to implement the back propagation by hand. Everything complicated is done by PyTorch. And a good thing of PyTorch is you can enjoy the original Python control structure. But it's a little, as you know, PyTorch is a little bit slower than TensorFlow. So if you really want to get a speed, you should use a TensorFlow, but you have to understand how to use TensorFlow. It's more complicated. So just in case, let me introduce shallow embedding and deep embedding is very famous thing, but just in case, let me briefly introduce the differences between shallow embedding and deep embedding. It's like a tutorial, but if you understand perfectly, just ignore this part. So there are two ways to implement embedded DSL. One is shallow embedding, and one is deep embedding. And I believe deep embedding is more advanced, and we should push it. But unfortunately, PyTorch based in shallow embedding is a classic one, and it's sad, and it's more popular. It's sad. It's maybe our research activities too early to get accepted from the community, from normal people. But anyway, this is an example. No matter which you use, shallow or deep, the user's code is very similar. So in the DSL, in that kind of DSL, the user write code using operator overloading or method chaining, or in Scala and Ruby, you can omit lots of parentheses, so you can write a little bit more natural representation. But anyway, the idea is the same. It's a bunch of function calls is combined, connected through operator overloading or method chaining. So this example says you have a matrix object M and also vector object P and Q, and you want to multiply. You want to do M multiply P plus Q, right? And in shallow, if your language is shallow embedding, you can only write a blue code. You don't have to write a red one. But if you use a deep embedding, you have to add extra weird thing, run. You have to call run method at the end. So this is shallow embedding. What's going on? It's very simple, straightforward. It's very classic. So basically, in shallow embedding, a method returns a value. So if you run this code, m.multiply p.add q, when you call m.multiply p, the method takes a vector p and matrix m, and returns a vector object. It's very simple, straightforward. But if you use a deep embedding, which is used by TensorFlow, methods return not the value, but an abstract syntax tree. So if you call m.multiply p, it returns an AST, it's like this one. And this red one is called materialization, but I will tell you later. But anyway, in deep embedding, a method returns an abstract syntax tree, not the value, not the matrix object. So after that, if you call add on that returned value, which is AST, it returns another AST, abstract syntax tree. Now it's represent plus m times p plus q. And finally, you have to run. You have to call the run method or compile method or whatever to end this chain. And the run method basically run method is defined on AST. So it is supposed to interpret or run the AST as a code and make a value. So that's an idea. And of course, the run method can generate, well, C++ code and compile it and dynamically load it onto the memory and run it. So then you can get the very fast execution speed. But anyway, the idea is basically expression makes a pass tree, abstract syntax tree, and at the end, compile and run it. So that's the basic idea about deep embedding. And this, as you see, this is obviously better or more advanced way to implement DSL. And this idea is not only for TensorFlow. Another famous example of the library language using deep embedding is Halide. It is very famous DSL written in C++ and available in C++ for image processing. In this language, it's C++. You can write this code with C++ editor and compile it to run it in with C++ environment in C++ environment. But it's embedded new language. It's not C++ at all. But for example, it's not declarative. Like 1, 2, 3, 4. The fourth line says blah x function is defined like this. It's a declaration of the it's function declaration. But under the hood, again, abstract syntax tree is constructed when you call input, and 3 input functions that returns abstract syntax tree, and plus operator is overloaded. So the 2 abstract syntax AST is combined into 1, and the second plus makes another tree, and that is given to blah x object, maybe equal is overloaded and defined. So things like that. So it's totally new language. It's not C++ at all, but it's still in C++. So let me then that the end of the example. Let me introduce some little bit more research topic. So because if you use embedded DSL, you can really implement nice library language. Because it's called a language. Well, we want to enjoy more linguistic things, language things, Like first thing is a syntax error. If we call it language, we want to do some syntax checking before, running it. So the question is how to check the syntax of DSL code. Here these are examples. So because we are implemented SQL library, so select from where that's okay. But this should be error, because we first call select from and then from again. It's kind of weird. So, but if this is a real language, this should be syntax error because select from after the from where should come. So this should be syntax error. It's not a semantical error. And the point is, in the viewpoint of a host language, in this case, some Java-like language, this is totally valid. From the syntactical viewpoint, this is totally valid. And this is also totally valid. But from the viewpoint of DSL, the second line should cause a syntactic error because it's not valid in the sense of DSL syntax. So the question is how to find this. It's known, the technique is known to do syntax checking by using types. So if you carefully design a library with some nice types, you can detect syntax errors of DSL by using host language type system. So the idea is very simple. So select, in this case, select method has to return SQL1 class, SQL1 type, which has a from method. So you can, to follow that, you can, by following that, you can call from method because it's defined. And from method returns another class, SQL2, number 2, and it has a where, it only has a where method. So this method call makes an error. Because from the viewpoint of the type system of host language, this is the obviously type error because the receiver type is SQL2 and SQL2 doesn't have from method. So it's a type error. But this type error should be interpreted as a syntax error in an embedded DSL. So that's a trick. So, and then the second question is, what kind of grammar class can be processed by this idea? And it's because if you adopt this this approach, you have to define lots of classes, lots of types and classes to implement your library language. It's very tedious. So many people propose and developed a DSL generator or method chain API generator, which read a grammar definition and grammar definition of the DSL and generate kind of library code skeleton, which contains lots of types. I mean, to do syntax checking. And an algorithm is quite straightforward because, for example, if we want to do LR parsing by types, the things that this kind of generator has to do is to emulate LR automaton by using types. And the behavior of automaton in a type system is very similar because the automaton has a state and takes a token and moves to another state. And a type system is also do the same thing. It takes a receiver type and method name and finds a return type. So it's easy to emulate this kind of state transition by using type system. So again, many people propose the idea solutions to do that. Because LR parsing, to implement LR parsing, you have to implement error automata, which are kind of push-down automata with jumps or epsilon transition. These jumps, how to implement jumps and epsilon transition is a little bit complicated, but it's possible because, as you know, Java generics is now Turing complete and so on. So it's technically possible, but it's a real challenge is how to implement. For example, Grigor proposed wrote a paper at Popl 17. He proposed a subtype machine, and which is Turing complete. So it's possible to emulate error automata. And Fling is also used in Java generics. And the third one is the paper from our team, which is a type level error. The former two are using the Java generics. But according to our experiment, the type system of Java was not implemented or designed for doing this kind of crazy things. So if you really use a regular subtype machine or a Fling, and the length of the code, DSL code, the length of the chain is long, then type system got messed, and it can compile, it can do type checking, but it's extremely slow. In principle, the computation time should be linear, but the reality is not. The compilation speed is kind of exponential. So we tried to find another way, and we found that it's not available in Java, unfortunately, but in Scala or Haskell or C++, you can enjoy much more powerful things like, in case of Scala, Haskell, you can use function overloading by using implicit parameters or type classes in Haskell. These are also Turing complete, so technically not really true. Sorry. But it's very strong, powerful. So we found a way to implement type LR automata by using function overloading. And we actually ran the compiler and see it's not really, unfortunately, it was not linear. The computation time was not linear because of some implementation problems, but the speed is pretty close to linear. So it's much faster in practice. Another issue is subchaining, because idea is the same, but if we want to design a library language by using method chain, you might want to use a slightly different style, which is called subchaining by us. So this is normal chain, right? Flat chain style, which is just a sequence of method calls. And if you use a Scala, you can omit this dot and parentheses, so you can get more readable code. But in Java, it's not available. So you might want to split this long chain into two separate chains. And first you make this subchains and give this chain as an argument to this where method. So the resulting AST should be the same. But the way of coding that is slightly different. And the question is how to produce this API skeleton from the grammar definition. And a bit complicated. So these two are from our papers. The first one is a silver chain, which is a tool to generate a library skeleton from a grammar definition. That this system read the grammar like this, and in this case, from where clause is a non-terminal symbol, and this non-terminal symbol is defined like this, like as usual. And in this case, superchain read this. When the superchain finds this non-terminal symbol, which generate API skeleton, which accept both flat chain style and subchain style. So for every non-terminal symbol, which generates the API, so you can define where, following the where class is a static method, and define a subchain and give it to the where method. And you also write kind of flat chain style. So the system read the grammar and try to process and translate and blah, 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 and then finally generate. And when we proposed a silver chain, at that time, we didn't really understand which kind of grammar class is accepted from our algorithm. It was unknown. So yesterday, we presented another paper, which is sort of a simple paper, but we finally found that, the solution was simple. If we use this slightly different algorithm to generate this, LL1, at least LL1 is acceptable, except some minor exceptions. And we wrote a proof and presented it yesterday. And another topic, if you want to use a chain style library API, you have to consider lots of things to make it practical. And another issue is, okay, syntax error is found by using type system. But what about the types? Types in DSL. Of course, types in host language is checked by type system of the host language compiler. But because now library language is called a language. So why not introducing a type systems for DSL, not a host language? And the question is how to type check, how to do type check. And a paper 2 years ago was about protocol, which also read a grammar definition and generate an API skeleton, but it allows you to use type parameters for your DSL. So in this case, it defines a form. It's a kind of map, hash map, but like a stream API of Java, you can use type parameters here. So if you put New Zealand 64, which is the phone number, then the type variable B is bound to integer and K is bound to string. And then this one is valid because Japan is a string and 81 is a number. But this is accidentally this is the wrong order. So this is type error. Well, it's not complicated. But our proposal is that the API generator has to consider, type parameters for DSL library. So we have to do lots of things. And of course, the type skeleton generator has to do kind of analysis of when the type parameter is bound. And in that case, we have to slightly change the generated types. That's all. If you are interested in that, please read the paper. So let me wrap up. So far I said about syntax checking and also type checking, but our protocol does only very limited type checking. It's not really type system. It's not really type system for DSL. It's kind of unknown question. Maybe we need a little bit more complicated type checking scheme based on the host language type system or host language something else. Because anyway, library language is a library again. So it should use the functionalities provided by the language, host language, as much as possible. So maybe we should come up with good ideas for editing and coding supports of DSL code on top of host language environment. And also debugging is an issue. If you use embedded DSL and if it has an error, it's going to be hard to do debugging. So maybe we have to use a host language debugger, but it's not clear how to use it for DSL. That's a missing pieces, and it kind of should be a future work. That's all. These works presented here as our own work are not my own sole work. It's a basically collaboration with my past students. So I would like to thank all these three guys in particular, Kazuhiro Ichikawa and Tetsuya Yamazaki and Tomoki Nakamo. Tomoki is over there. Thank you for them. That's it.
Thank you so much for such an interesting talk. And time for questions?
Yeah, this is the microphone.
Okay, maybe you can use.
Yeah,
I will argue that there is a thing that intrinsically a library cannot do, and it is to actually prevent the programmer from doing something. So the thing that you really need a new language to do is to preserve new properties. You can add a library that can do new things, and inside of that library you can preserve that while using that library you cannot do certain logical violation. By virtue of being a library added to the language, you cannot prevent the user to do whatever logic outside of the library. You know?
So you mean why I don't develop an external DSL sort of? Why do I want to stick around the library?
No, I think that sticking inside of the language is definitely a great idea. I'm just saying that you can distinguish a very advanced library from a language because the language can enforce new properties by actually restricting what the programmer can do.
Mm-hmm. Oh, I see. So you wanted to use more integration of a host language and a library DSL. Yes, but I think it's for learning because it's. As far as I believe, the people is not good at learning many things at the same time. So they tend to want to focus on one aspect at the time. So for that purpose, providing a library, kind of set up a kind of small world to do some specific thing is a good idea. So that's why I think the DSL should be a language, not a library.
Mm-hmm.
Is that okay?
So yeah, I will argue that basically you can leverage on top of what you are saying and saying that the role of a programming language should then be to, on one side, have a syntax that allow you to have those kind of DSL working well in it.
Yeah,
and
but
on
also
the other
abstraction
side,
abstraction is more important, and the language provides an abstraction. Yeah.
Hi, Professor Chiba. Thank you for the amazing talk. I really like this research, and I think if you had the opportunity to design a new language that has more freedom, or was not so much like Java. What are some features that you'd like to see in the host language that would give you the flexibility to do all these DSL?
Oh, okay. Honestly speaking, I've been to stick around this idea, extensible language, when I started my career. I remember that my first presentation, major presentation was ECOOP, and I still remember that my last slide at that conference was where we need extensible language, and but unfortunately I couldn't find that slide. So, but anyway, so I really wanted to have an extensible syntax. Because to change the semantics nowadays, we have a bunch of techniques like meta programming and method chaining and type systems. But we still only have macros for syntax extensions. And the ability of macro is very powerful, but the macro is also still problematic. So I would like to see a widely used language which supports more advanced techniques.
Do you think it's necessary to have Turing completeness in the type system?
Thank you.
More questions? I think.
To be honest, I'm a bit skeptical.
Okay.
In my career, I've seen too many programming language or DSLs. Many of them designed by scratch. Many of them obviously designed by people with no expertise in compiler construction, let alone language design. Of course, I don't mean you. And,
thank you.
And they had very user-friendly features like a fuzzy or flexible syntax where you could add or leave out parentheses, semicolons, and so on, which led to all kinds of nasty things like nasty surprises like ambiguities and so on and so forth, and which led to the fact that the developers were fiddling around with the language all the time so that they were a moving target rather than a solid standard which should be valid according to AITO standards for 10 years at least. And so my real question is, should we refrain from defining a new language unless we are absolutely sure that it is necessary? What I mean, can't we use a standardized existing programming language? My favorite one would be AITO, but that's a matter of taste, of course. And then we are absolutely sure that we can also, when we use a subset, then we can also always use towards the direction of the full language.
Oh, okay.
Yes, of course, a small library would be sufficient.
Okay. Let me answer your question indirectly. I favor of democratics. Well, 20 years ago, the world was dominated by C++, and that was very sad. And Java came out, and language community got a little bit happy, I believe, at the time. And nowadays, so many languages are presented. And yes, as you said, most of languages has flaws and problems. But because the number of new languages is so many nowadays, and people are more widely accepting using new ones. If I talk to young students, they prefer to use. They always want to use the latest new language, and because the number of new languages are many, in the goodness of democratics. After a few years, only the good languages remains, and other bad ones is discarded. But good ideas, still remain from that. So then, technology is advancing. So that's, I believe.
We have time for one question.
Thank you. Thank you for your talk. Really inspirational, I think. In the past, I had some experience with Scala and embedded DSLs, and I got the feeling that at some point, who is writing the DSL is tend to add methods that doesn't do nothing, just in order to have a nice syntax or bring things around. Is this not tend to polluting your library, your DSLs at the end?
So you say the style of coding of DSL is not good enough today? Is that your point?
Not really. At least this is maybe a Scala issue, because we are going to tend to use a lot of implicits, and you need some dummy methods that just
I see.
trade the type from one to
Well,
another.
the reason is, Scala is nice, new modern language, but it's still under the development. And, Scala people try to make the language much better, Scala better. So the specification of Scala is changing maybe too quickly, too fast. But I'm optimistic to be, in future, the Scala is going to be a good language and avoid all the problems you found today.
Okay.
So I'm a researcher and I'm very optimistic to the future.
Okay, so we could have some quick question if anyone else has one. Okay. Quick one, please.
So when you were talking about finding syntax errors in the embedded language as type errors in the host language, I was curious. It seems that for you would need particularly expressible behavior in the type system of the host language, but it's also kind of been a trend recently to explicitly restrict the types of computations you can do in the type system for numerous benefits. I was wondering if you thought that trend might interfere with the idea of embedding but possibly very rich syntaxes in a host language.
So you mean it's kind of a way I presented today is sort of how do I say, it's kind of bad way of using a type system. Maybe yes, but again, we are a researcher, and we have to propose a new kind of weird, tricky technique to the community in the industry, mainly in the industry. And I think one of the very important activities here, people from academia, is to show, hey, this might look very weird, but it's a useful thing, and please accept this idea. Embedded ESL stuff, is invented a long time ago, and still industry is slow to accept that idea. But they gradually accepting. As I said, that TensorFlow, I would like to push TensorFlow, but still too early. It seems to very early, too early. But maybe in 10 years, 5 years, new library for machine learning will come out, and I hope it's based on deep embedding. So yeah, you're right. But if I accept your thought, I will lose my job. Thank you.
So thank you so much for
Thank you very much.
interesting
listening.
keynote.
And great questions.